So as you see, as we're a couple minutes past, we'll get started right away. What we're talking about today is our graph-centered AppDev video series, and we're looking at episode 3, master data management. And really the focus of this series is on how to create powerful applications with graph at their core. So as we look at the schedule, you can see that we are on our 3rd session. We've done a session on what's wrong with your application, focused on all of the ways that older application design with relational databases, tabular databases at the center, can present issues as you try and scale and grow over time to meet new business needs. And then we focus specifically on what are the strengths of graph databases for your backend as the core to an application, rather than as an ancillary piece on a relational database. And today what we're going to focus on specifically is a really important aspect of having a strong business application is master data management. And so we're going to take about 20 or 30 minutes today and talk about master data management. We'll talk about how this was done before Graph, and then we'll talk about the power of Graph for solving this use case, followed up with some specific use cases that we have looked at with our customers, and a demo of using the Hume platform to do master data management, and then some question and answer, of course. And so as we look through this, we want to just start by defining master data management. I'm going to see if I can turn my camera on. I don't seem to be showing anything on my camera, so we'll leave that off. But if we go on towards the definition of master data management, or sorry, if we start with our review of our graph-centered AppDev, this is a sort of typical application stack that we see with a lot of our clients. This is actually available as a handout that we can share right now, and you'll be able to download. And what we see in this handout, or in this diagram, is that there's a lot of different needs that applications serve, and serving that flexibility can present a major challenge for old style applications. And so for certainly consumer facing or SaaS applications where you have full control over the architecture, this is really the best practice that we are recommending to all of our clients now as we go through our application development projects. For internal business applications where maybe you're not hosted in the cloud, or there are other restrictions, there may be some modifications that we would make to this. This is really a typical best practice that we would see. And what we're going to focus on today is really that connection of cloud data sources to our backend, because that's often where the issue of master data management comes into play. And so what is master data management? Well, as we take a look, we see that master data management really falls into 2 buckets based on our experience. And those 2 buckets are data resolution, which really presents the master in master data management. And these types of use cases require identifying a single master record from a collection of records. So this is that combination of customer 360 is sort of the buzzword that people talk about now. Or you can see on our right-hand side, we've got like Google Ads, CRM, Snowplow, some event-driven systems. What we're trying to do is we have someone who's at our marketing funnel because they've clicked on an ad campaign of ours, and then they go through our marketing qualified leads, and eventually they become a sales qualified lead. But it turns out that they use their personal email address in the marketing funnel. And so now as we go into the sales qualified funnel, we have their business email address. That's still the same person. And if we want to understand the ROI on our marketing spend, we need to resolve those 2 separate entities separated by an email address to one unique person. And that's the really topic of data resolution. And data lineage is more specifically around where did that data come from? And specifically looking at, okay, some of that data came from our marketing system in Google Ads, and then the sales data came from Salesforce. And what databases, what tables, what physical data elements did those pieces of information come from as we tried to unify this into a single record? And that applies to data resolution, but it also applies heavily to reporting and business intelligence, as well as regulatory use cases, where companies are constantly creating reports, and they need to understand at a point in time what comprised this report? What tables did it go back to? What were the business rules? What were the SQL rules that were being created in order to make this report, and understanding how those change over time. So if we focus briefly a little bit closer into our data resolution use case, you can see that any company is going to have a number of different platforms, whether it's their web team, data warehouses, NoSQL systems, data lakes, or even departments between CRM, sales, marketing, finance, HR, data formats, just Excel files, schemas, unstructured data, object storage, and systems like their ServiceNow or Salesforce, Slack, Office 365, and even different divisions between product lines or groups of an organization. And each of these systems or each of these own groups are going to have their own different schemas. Even within the platforms or even within your departments, there's going to be individual schemas in that group. And if you move between all 5 of them, you might have, at least 5, if not hundreds of schemas, depending on the size of your organization. And you're going to need data from all of them. And this is something that, as we've gone through our reporting focus as a company, one of the top complaints we find in working with new customers is that users don't have access to the data they need to make decisions, and it's hurting their ability to innovate and drive their business forward, because we're spending too much time trying to navigate between all of these individual schemas to get the results that they need, rather than actually make decisions based on the data that they already have and that we can connect together in a graph format. And so using the graph, we can help to resolve all of these different schemas and understand a single version of truth of an individual entity. And as we look at data lineage as well, we can see that we think about data lineage as a cycle. And so we have a report up at the top that we're generating, and that report comes from regulatory requirements and business rules, therefore driving towards databases, tables, physical data elements, and eventually a reporting tool that's generating the visualization. And this is a cycle that's happening constantly. So even when we don't have this error resolution sort of special event, this cycle happens constantly. Regulatory requirements change, business rules change, we adapt and improve our business, and how we define our reports is going to change over time. And this repetitive and flexible cycle must be tracked at each step along the way. We struggle enough, we've seen our clients struggle enough with just reporting today, that requests like, show me what that report looked like 9 months ago, often present an untenable challenge. And we can take this complex process and track that element of time using the graph database in order to understand how these interconnected systems produce these reports at any point in time. So if we look at the old way, how people handled master data management, and specifically data lineage as well, for those of you who are experienced and have suffered the scars of business intelligence, you may recognize IBM Framework Manager on the right-hand side here. And this is really the path of centralization, restriction, and glacially slow progress in companies. And as someone who's been in BI for a while, I have sat down and spent more time than I would like to in Framework Manager. And it's really indicative of the old way that companies try and deal with this, which is bring all of our data together into a central location, define all of our joins, have IT handle the whole thing, and then when businesses want requests, it's going to be an 8-month development process, because the whole thing is so brittle and inflexible that one change has cascading impacts throughout the entire thing. And it really makes it difficult to do anything and make any progress, because we can only connect our data in one specifically defined way, navigating from, quote, far away places in our schema. So if we have data from marketing, which is connected through sales, which is connected through our product orders, which is connected through our coupon system, getting from marketing to the coupon system is requiring a number of join tables, potentially calculations that are being done in memory, based on metadata from Framework Manager or other tools. And it can become incredibly slow, as well as very difficult to understand the connections between the data to build reports and to get that information out. And so if we look at this process, how can we then use graphs in order to help make things better? When we look at the power of graph, the power really lies in these relationships that we see on our screen here. And so what we see is that using these relationships, we can track these synonyms and related elements for data resolution. We can take individual entities that are disparate but potentially related and bring them together with relationships. And no matter how long that path is, because the cost of traversal is so low within graphs, we can make that jump without any query cost. We don't need 10 join tables. We aren't going to be crippled by computing all of these things in memory and scanning through all of our tables at the same time. We're able to simply look at one element and traverse down several relationships to the next element. And similarly, we can do that tracking of history, both for our data resolution and our data lineage. The term slowly changing dimensions is probably familiar to many of you. And that's something that is incredibly challenging in a relational database. And it introduces really two major complications that you may be familiar with, which is you have to define a date for your report, often a specific date, but at least a date range, which is often hard to understand for users. And it requires us to define upfront all of the specific fields that we want to change. And that's because doing slowly changing dimensions in a relational database is so difficult that we want to do it on as few things as possible because it's adding a ton of complexity and a significant performance hit to our queries. And the last piece of why graphs are so good for master data management is that you can easily navigate these loose and temporal hierarchies. And this is something that we've talked about in a couple of blog posts recently, but hierarchies are incredibly powerful. However, when they become too strict and we start forcing products or people or communities of people into groups that they don't belong in, we start losing the power of the hierarchy because we're basically form-fitting, we're trying to put the square peg into the round hole and form-fitting people into an area that they don't belong into. And graphs allow us to actually keep these loose hierarchies and have people be in two different components of that hierarchy and use weightings on our relationships, or have that hierarchy change over time. Potentially one category in our hierarchy is no longer needed. We want to modify it, change some of the grouping on it as well. And this is really highlighting, and we'll show in a second in Hume, how graphs can really drive master data management. And it's just talking briefly about a couple of our specific use cases for Hume, for master data management. One of the top ones that we see is regulatory compliance. And we've seen this at a number of top financial institutions where companies or institutions are looking at how am I satisfying regulatory requirements and how do they change over time? And often this looks like understanding how did I deliver this report back in January of 2018? What were the physical data elements and reporting structures that I was leveraging then? And that can also look like how do my business rules change over time in order to better satisfy these requirements? Because you might get feedback from regulatory bodies saying, this data point doesn't sit well with your peers. Can you give us some more explanation as to how you got it? And they'll have to come back and say, okay, let's look at 3 months prior. How did we submit this report? What were the business rules? Okay, we can see that we have a physical data issue on this system, and that's impacting this regulation. And that way it lets them get an answer quickly and efficiently to regulatory bodies without massive headache, months of time trying to go back in time and recreate things. And then again, on slowly changing dimensions, this is something we see across all use cases. Basically, in every application that we build, there are things that we want to track time on. We want to look at how did this quote change over time? What is the history of this product? Was its price going up or down? And all of these things are possible within a graph database using those relationships by creating chains of elements. And so we actually will chain together the number of different elements to represent history, which allows us to keep our connections along the chain, but also always keep a reference to the most current aspect. Another really strong use case that we've seen for master data management with graphs is data science, where we're doing a lot of data manipulation prior to running our models. And we need to do, especially on a lot of the automatic models that we can run these days, you want to do a lot of cleansing, a lot of trying to unify disparate people into a single, different customers into a single customer, as well as connecting data from all of those different systems. And doing that process in an ETL flow or in something like Python or R can be extremely challenging, but using our graph, we can bring all of that data together, do our joins and complex processing in the graph database, and then take that data structure and push it into some of these more automated data science tools. And then lastly is just in basic data processing and in ETL. We worked with one of our clients on a process where it's another large financial institution that was receiving loan and banking documents from thousands of smaller financial institutions, thinking local banks type setup. And they found over time that one of the biggest problems they had was that people had different names for fields. It might be first name, last name, or it might be first underscore name and last underscore name, or it might be all joined together a name. And they were having a really hard time when there were issues with data talking to these local institutions about it, because they all were referring to the same column with different names. And so they actually used Neo4j to build a custom data processing pipeline where they could ingest all of these varieties of schemas and bring all of them to a unified standard schema, but keep that reference back to the original data source name and column name. And that did a number of things for them. One, it automated their process so that it was much faster to get these documents and have them show up in a unified schema. But it also meant that when there were errors, they could go talk easily and quickly to these partner institutions and get them resolved. And that ended up saving them huge amounts of effort over time. So I'm going to pause sharing on that slideshow for a moment here and start sharing a specific window because I want to take a look at how we can use Hume to do some aspects of master data management. And so Hume is a graph-powered insights engine created by GraphAware that we resell in the US. And I want to look at a couple of different aspects for it for master data management. One of the most powerful things that we can do in master data management is to start looking at what is our data going to look like when it's unified together. And so when we start looking at this data, this is a beer use case where we have users who have reviewed beers, and we've done some natural language processing in Hume on that data. We're just going to focus on users' reviews in beers at the moment. If we open up one of our users, specifically our demo user 1, we can see that they have reviewed a number of different beers. And we'll only load about 500 of these. And once we've loaded 500 of their reviews, we can see that we've already grouped these nodes based on certain properties. And so we can actually see that these reviews are about the same style. And once I turn off this grouping, we'll see that this visualization becomes almost untenable. And this is the power of master data management, is taking a visualization like this, which is meaningless, and turning it into something more powerful. I'm actually going to add in as well the beers that are within this group. And so we'll get all of the beers that these reviews are about. And again, we'll see that we have really a mess of a visualization here. And using Hume, we can leverage one of our powerful capabilities here called computed attributes. We can actually compute at runtime certain attributes of nodes. And this allows us to test some of our master data management queries at visualization time without having to write that information to the database. And we can rapidly iterate, as we might not have the perfect fit solution immediately, but we can develop it quite quickly within the Hume platform. And so we can look at something like our review style attribute, where we're actually taking the review and computing which beer style that review is about. And then once we have a computed attribute, we can set up our node grouping and group our nodes together. And this falls under the data resolution use case that we were discussing earlier, where we want to know, okay, we have all of these different reviews about different styles, and I know that there are similar styles in here, but which ones are about which? And so if I enable this grouping, you'll see that we move from a visualization that is essentially meaningless to a very clear and optimized visualization. And what we, taking this beyond the beer use case to a broader picture, these might be, if we look at some of our styles, even though we're looking at styles and beers here, this could just as easily be individual instances of the same user and references to that user in different systems. So we might have our marketing systems and our CRM systems and our order systems. These are all different instances of an identical user that we've now been able to resolve to a single instance and group in our visualization. And this is incredibly powerful because it means that, again, we can keep that data lineage. We don't have to simply erase of our user in our separate systems. We can keep them, but visualize them together as one individual entity. And this is really powerful as you have different users within the system, because you may be having your marketing users in there, and they're going to know the marketing fields and the marketing database and want to reference all of their information using fields that they are familiar with. And that's really the power of keeping that data lineage, is that you not only get the value of being able to leverage relationships to quickly connect things and get to a single source of truth, but you get the convenience of your users being able to understand the data in their own native language. And the efficiency of that to drive businesses forward really can't be overstated. It's something that we've seen time and time again as we go into our clients. We're often trying to say, okay, how does this Salesforce data connect into this Google AdWords data? And we're bringing together two departments that don't talk to each other often enough, frankly, and they don't understand the other department's data. And so we come in and we bridge that gap. But then once we've left, they're sometimes unable to keep bridging that gap. But when we introduced a graph database, they each can continue to talk about the data in their own language, and that graph is filled with master data management on Neo4j using the power of these relationships. And as we look at just one of our other use cases for a second here in terms of master data management and doing some of this rapid prototyping, I'm just going to bring up another demo that we're doing here where we're looking at market analysis. And so we're simply processing in RSS articles, and we have some combinations of structured data like categories and authors, as well as some unstructured data like keywords or mentions, organizations, and people and locations. And we'll see in organizations that we have really a variety of organizations in here. And we can do a few things using the Hume platform. One of the things is we can start with that same sort of process, and we can search by some of these organization names. We'll take one example here, like the Federal Reserve. Search here. We can start searching for some entities that we know are in our database, so we can see the different examples that might be present. So as we can see, we have a number of different Federal Reserve node instances here. We can actually start to just do queries on these as if they were the same entity. And so I can understand what are the keywords for this organization. And we can see that for all of these instances of the Federal Reserve, these are the top keywords that are relevant to them. And that's simply by leveraging the fact that as we expand these organizations into articles, and from these articles we can expand into keywords, we can navigate we can navigate through all of these different connections incredibly rapidly with the limited cost of our relationships. And as we're moving between all of these different entities of Federal Reserve, we can navigate these specific keywords and understand that there's actually some limited, despite the number of here, the different instances of the Federal Reserve naming refer to a few central keywords, which can get us both the most important keywords to the Federal Reserve and help us understand an individual instance of the Federal Reserve. And then the last thing that we can do with the Hume platform is sometimes master data management actually can involve enriching data with other pieces of information. So we may want to be processing these RSS feeds and extracting organization names and then enriching that information with external ownership structure or external corporate data. And so one of the things that we've done in some of our use cases is use the power of Hume Orchestra. And we have within Orchestra the ability to create calls out to external APIs or even internal APIs. And we can use this HTTP enriching skill to actually within the platform enrich our data. And so we've looked at using things like the open corporate data in order to enrich information. And so we might be able to do something like search Federal Reserve. And so we can see a lot of different companies that may have the name Federal Reserve in them. And if we looked at some of our search results from Hume, back in this visualization, some of our instances of Federal Reserve may actually resolve to these companies, or they may resolve specifically to the US Federal Reserve. But we can take this structured data and list of related companies and unify it alongside our unstructured data. And we can quickly extend out our schema to say things like we might have a related organization. So if I draw a relationship here, we might have related organization. And now in our queries, we can quickly navigate through that chain of related organizations to start identifying communities or individual instances of organizations. Go back to this presentation here. And so that wraps up our webinar on master data management and the power of graphs. We looked at how graph databases can help with master data management for both data resolution and for data lineage use cases, as well as the combination of both. And at this point, we'll go to the chat to see if we have any questions. And I see one in the chat here of, should we migrate completely off our existing tools, or is this a complement? So we really see graph databases as a complement for most master data management use cases. While for graph-centered AppDev, we would recommend building with graphs at the core. For master data management, the use case here is that you already have a number of existing systems, and it's simply not feasible to rip and replace all of them with a single graph database. And so we'll typically see this as a complement and serving as sort of middleware for the interaction with data. And looking at one other one here, what kind of technical skill would be required from our side to implement an MDM solution like this? Just a plug for us is that obviously we do graph database consulting, and I've worked with a number of different clients on this solution. So if you leverage our expertise, the technical expertise can be low. What we typically see is that these projects actually results in less effort from the clients long-term than their current solutions do. But in terms of maintaining it, you're looking at skilling up on some Neo4j skills, and depending on the technology we might leverage for the middleware, looking at those technical skills as well. And then just the last one here is, what are some benefits to basing the master data management paradigm around graph versus typical relational structure? And this is something that I think I've talked about, but just to really highlight the point is that it's the power of the relationships. And that's why we work with Neo4j, which is the leading enterprise property graph database. And why the difference between a relational database and, confusingly, a graph database, despite the fact that relational has relation in the name, they're actually really an Achilles heel of relationships, because navigating between different tables often requires these intermediate join tables or complex SQL statements, or sometimes just straight lookups and subqueries. Whereas in a graph that is a graph database that is really truly native, that relationship, it's stored on disk pointers from the different elements, and that makes the traversal so much faster that it's really just not a competition. Graph databases really are the future, both for master data management and for everything else as well, and our most other use cases, in our opinion. We do have another question here on how do you manage restrictions on edges. So that's a really interesting question. So actually in Neo4j4, they released node and relationship level restrictions where we can let users traverse certain nodes, but not actually return information on that. And depending on the use case for restrictions, that's something that can be managed with properties on the edges, or something that also might get managed in the middleware if we're looking at like a data service API. That's a great question. If there aren't any other questions, we'll wrap up here. And the slide deck also will be available. It should be emailed out to you at the end. We've got just a couple of resources here that we recommend on master data management, looking at graph databases and some of the solutions out there. And as always, please feel free to reach out to us at contact@graphable.ai and head to graphable.ai/events to see more of our upcoming webinars, or blog posts, and some of the content that we're putting out there constantly. Thank you guys very much. Appreciate you taking time on this Tuesday to learn about master data management with us, and everyone have a great day.